This conference will now be recorded.
So today we'll be discussing optical instruments and human eye. So optical instruments are devices which use mirrors, lenses, prism, and what is the use of these optical instruments? To extend the range of the vision of human eyes. Okay, so we'll see range of human eyes actually is limited. We'll see in the human eye part. So what is optical instruments? Optical instruments are devices which use of mirrors, lenses, prisms to extend the range of our vision. Okay, so if I give you some example of optical instruments like microscope, what it does, it helps to see very tiny objects, tiny objects clearly. Okay, and if I say telescope, it helps to see distant objects. Okay, so optical devices or optical instruments are actually helping tools for the human eyes. So the objects which we cannot see with our naked eyes, like very tiny objects, like microscopic objects, or even nowadays nanoparticles can be seen with electron microscope. The basic principle of microscope will be the same, but now in our 21st century we are actually not exactly using light microscope for everything. Now we are doing so light microscope. These are already there, but modern science advanced far better, like better position, and nowadays we use electron microscope, then compound microscopes. These are advanced microscopes which helps us to see very tiny objects like nanoparticles, then microbes, okay, and very tiny bacteria, etc. with this powerful microscope. Anyway, so these are optical instruments, and we'll see what are the purpose of optical microscope. Then purpose we have already discussed. One, to form an image of close lying objects at the least distance of distinct vision. That means if something is there at very near to your eyes, you cannot see. It has to be pushed little distance. So in fact, you can see to increase the range, increase the range of our vision. So this is one point. Second point is to see any objects with a magnified figure. So I mean to say, okay, to see magnified image of any object, to see any object magnified. So not only that, to increase the resolution, I'll tell you what is resolution. Resolution means if there are two objects nearby, like see there are two things nearby, like this, very close to each other. If some microscope, they can see these two objects distinctly, then that is having greater resolution. Suppose something is, see there are two candles, suppose two candles, okay, nearby. Two candles. If you are seeing from very far, you might be thinking a big candle over here, isn't it? You might be thinking a big candle like this over here. Okay? Instead of seeing this individual these candles, you might see a big candles like this. Okay? But if your telescope, if you see from very far, if your telescope has better resolution power, they can see these two distinctly. Similarly, if you have a very tiny particles, very tiny particles which cannot be seen in our naked eyes, even if you see naked eyes, they will not be visible distinctly. You might think like there are like something like this, okay? Some object which is extended like this, okay? So you may not be able to distinctly see these 2 points to like these 2 points, okay? Distinctly. You cannot see distinctly. You might see something like this together, okay? You'll see something like this together. But if your microscope has better resolution power, you can see this distinctly. One person can see these two distinctly. So this is actually resolution. So to increase the resolution power or resolving power, I can say to increase the resolution power, or this is called resolving power actually, resolving power. Resolving power. To separate out two very closely spaced objects and makes us to see them distinctly. Okay, so this is to increase the resolving power, to see any magnified image of any object, and to increase the range of our vision. So these are the purposes of using optical instruments. Now we'll see, okay, essential features of. So I think I would have kept this written. So let me just repeat this. To increase range of vision, to magnify, and third is to increase the resolving power. Okay, and what are the essential features? Essential features are that, see, as I said, magnified, so it has to have high magnification, high high magnifying power. Okay, so this has to be high. Then second thing is adequate resolution. Resolution. I have already told this. So these are the essential features of the optical instruments. So any small object we can see in a bigger size, that is magnification. So as you know, magnification is given by the height of image, magnification, linear magnification, height of image by height of object. Okay, this is magnification. All right. So if the height of image is large, then magnification will be more. If the height of object is very very small, then also the magnification will be more. If yeah, so height of image is remaining same anyway. So now what we'll see, we'll learn one of the most amazing instruments which human actually human being has. One amazing, and it is, you can say, the gift of God, that we have eye. Otherwise this world will be meaningless. We cannot see, we cannot describe, we cannot do anything else with this. So eye is most valuable and sensitive organ in our human body. Now see, we have actually five sense organs. Among them, this is most sensitive. So our body has some natural sensors. One among this is the human eye, which can set, it is actually sensitive to the visible sorry visible part of electromagnetic EM wave, electromagnetic wave, which is called light. Okay. So it is sensitive to the visible light in one sense, or visible light, or simply light. Okay. Now we see actually how we see generally, if any object is there nearby, our eye is actually having all the things like a camera has. A camera has a camera has a lens, that it has focusing lenses or focusing tube, etc. And then it has a film to keep the record of the images formed by the lens, etc. So human eye is actually a natural camera, and it is dynamic, not static. It is dynamic. Okay, it gives dynamic images. Okay, not the still images. We'll see the construction of, or the structure of the eyes. There are many important parts in the eye. First is this cornea. So what is cornea? Cornea is a transparent membrane on the front part of the eyeball through which light enters. See, this is a very very thin membrane, transparent membrane. Otherwise, light cannot pass. If the membrane is not transparent, okay. So cornea, you have understood. This is the transparent membrane in the front part of the human eye. through which light enters the eye. Okay. Now we'll see there is acro aqueous humor. Okay, some liquid in between lens. This is called lens, and this is the cornea. Between cornea and lens, there is a liquid. This gives this liquid actually gives certain specific amount of pressure to the eye, so that it it has a balance, good balance. So a aqueous humor is a salty fluid. It is saying that a salty fluid. So aqueous humor here. You look here. This is here actually. Aqueous humor actually is salty fluid. A salty fluid. Okay, salty fluid having refractive index how much? 1.1.337. So this salty fluid aqueous humor has 1.337 refractive index. Okay, this this actually fills the cornea, the portion between cornea or space between cornea and eye lenses. Now there is another humor. This is vitreous humor. You can see here. It is like it is covering the whole, almost the whole volume of the eye. Okay. This vitreous humor is like a jelly kind of fluid. Okay, jelly kind of fluid that fills the space between retina and human lens, eye lenses. Okay. So now we have something called iris and pupil. Let us see what are iris and pupil. So look here, iris is actually a diaphragm, circular diaphragm. You can see it is actually this one. This is iris. Iris is a circular diaphragm. Okay, and in between or at the middle point of this cornea, there is a small hole that is called pupil. See, these are the iris. Okay, and in between this iris, there is a small pinhole that is called pupil. What is this called? Pupil. All right, now we'll see this iris and the muscular action. The size of the pupil becomes smaller and smaller in brighter light and larger in dim light. So what is the role of this iris? The role of the iris is like, see, iris is like this. So you can see from here, this circular diaphragm, almost circular diaphragm, and there is a small hole. Okay, that hole is called actually pupil. And what is the role of iris? Iris actually, so they go and they can close the path because this is opaque. Okay, or okay, so these are actually so the cilia, sorry, iris is actually controls the size of the pupil. If there is bright light, then our eyeballs, okay, sorry, pupil automatically becomes very tiny, so that very less amount of light can enter through the eye. And in dark cases, in dark places, pupil, actually this iris they will make the pupil a bigger diameter so that large amount of light can enter into the eye or go through the eye lenses to make images. Now look, the interesting and most important part is the lens, eye lens. So it is a double convex lens. What is double convex lens? See, this eye lens is double convex lens. That means both side convex like this. Okay, both side convex. So that is actually double convex lens. Double convex lens, and it is composed of fibrous jelly kind of material. So the lens is made of crystalline jelly, obviously crystalline jelly. Okay, and what is the role of this eye? So sorry, eye lens. Role is that, so we have already learned lenses, right? The same role this lens also will take. Okay. So what is the role of a lens? Lens will create an image of certain object. So the eye lenses also will create images of objects, but there is a limitation. All, like, all the rays cannot be making images. So obviously we'll see there is a range of this lens. Okay, there is a range of this lens, and you can see there is a muscles called ciliary muscles which are attached to the edges of the lens. Ciliary muscles, these are attached to the lens edge. And what is the role of these ciliary muscles? To control the diameter of the lens. Ciliary muscles actually control the diameter of the lens. If the diameter is very thick, like when you need to see some nearby object, your eye lens has to be, or your focal length has to be very short. So in that case, your eye lens will be thicker, like this thick. Or if you have to do, you have to see far objects, then focal length has to be more, so the lens will be thinner like this. So this action is actually done, so making it thinner or thicker. So eye lens becomes thicker or thinner by the muscle sections of ciliary muscles. Okay, so it can compress it, it can release the compression, so that the focal length will be more or less as on when required. So we have learned what is muscle, ciliary muscles, etc. Now we have to learn what is retina. So retina, see, whenever you want to see any real object, sorry, real image of a real object, you need to have a screen where the image will fall. Okay, so where the image will form. Okay, so retina in our human eye acts as a screen, but this is not ordinary screen as we see in our lab. It is extraordinary screen. Why I'm saying extraordinary? Because see, inner part of the this retina, there are light cells, light sensitive cells. So those cells are actually called cone cell or rod cell. So these two types of cells are there on the retina. So what is the role of cone shape cell? So this cone shape cell sensitive to the colors, whereas rod shape cells are actually sensitive to the intensity of the light. So by this way, we can see that retina, in the inner wall there are light sensitive cells. And what does this light sensitive cells do? Actually, convert these cells convert the so convert the optical signal into an electrical signal. Electrical signal, and then there are nerves over here, and these nerves will go to our human brain. Okay, so see these cones, light sensitive cones, they will convert the signal which are coming up to, or the light which are coming up to the retina. So those light actually will be converted to electrical signal, and these electrical signals will be actually carried away by few nerves which are very very sensitive. So those nerves are actually connected to brain. These nerves are connected to brain, and then after reaching this, or after receiving these signals, brain will actually analyze the image. Generally, image is real and it is inverted in the retina, but our human eyes are capable of reversing the image. Okay, and showing you the corrected image or erected image, I can say. All right, so these are, so optic nerves, retina, ciliary muscles with vitreous humor, then ciliary muscles, then lens, aqueous humor, pupil, iris, and cornea. These are the important parts of the human eye, which we have discussed now. You can just go through your textbook, then you will get the details somewhat more, or maybe in a written form. All right, so now we'll see what is the specialty with human eye. When we talk about lenses, then we have learned lenses which have fixed fixed focal length. Generally, we have learned lenses with fixed focal length so that we can see some particular range. Okay, but human eye can see even 50 centimeter distance object and 100 meter, or maybe more than very okay, more than that even can people see. So this fixed focal length lenses will not be suitable for our human eye because it has to be flexible. Okay, so we'll see now how does human eye adjust the focal length for far distant objects or for for objects with smaller distance. So that is, so this accommodating the focal length and creating the image at the retina is called actually power of accommodation. What is this called? Power of accommodation. Power of accommodation means what? If we take a viewing glass and read a book, since viewing glass has a single focal length and fixed focal length, you cannot change the height from where you will be able to see or read clearly from. Or far off object also you cannot see with that fixed focal length lenses. But power of accommodation of the human eye is actually an important action of eyes, human eyes. What it does, it, see, by the action of ciliary muscles, we have learned ciliary muscles, right? See, by the action of muscle sections of ciliary muscle, this lens can be the focal length of the lens can be changed so that it can focus far off object, even near object. Look, I can show you that. See, this is called far point, far off object, and this is near point. Near point means a distance near to the eyes or the minimum distance of distinct vision. This near point is called minimum distance of distinct vision. Minimum distance of distinct vision. Okay, that means if you take a book or a page of book or a newspaper, whatever, if you bring that very near to your eyes, then you cannot read that properly. Okay, again, very far off object also cannot be seen very easily. Now look, this is far point, this is the maximum distance. A maximum distance of distinct vision. Distinct vision. Okay, so ciliary muscles, these are actually ciliary muscles. These are ciliary muscles which are connected to the lens at the edges maybe. So when it is actually, when we want to see far off object, the ciliary muscles get actually loosened. When they get loosened, then see, the lens will be thinner like this. Okay, so the lens gets thinner, so that focal length will be very very large, so that you can see far off object. But see here, if the lens is thick, then focal length becomes, so if you want to see nearby objects, then focal length has to be less than the far off, right? So suppose this is near, this is far. So when we need to see near objects, so you have to have a lesser focal length. So ciliary muscle actually has to be very very strong enough to compress it to make it very very thick, so that the focal length becomes very very less to see the nearby object. So that's why, see, since the ciliary muscle has to give pressure, a lot of pressure, that's why we feel pain sometimes to see very nearby object, and it is very very comfortable for eyes to see very far up of the objects. Okay, so this is called power of accommodation. That means human eye can change the focal length according to the requirement of the human eye. So that is what is called power of accommodation. Okay, so now we'll go to few defects of very common defects of human eyes which we come across for many people, and those defects could be corrected also easily by means of using external lenses to aid the eyes. Okay, so there are few defects. First defect is actually short-sightedness or myopia. So what is myopia? It is a defect in the vision. It is a defect of vision in which a person can see nearby objects clearly. A person can see nearby object very clearly. Clearly, whereas it cannot, so it cannot actually see the, yeah, so it cannot, so myopia means short sightedness. That means the vision will be, the range of vision will be very very less. Okay, it is a defect of vision in which a person can see nearly objects clearly. Okay, nearly object clearly, but far of object will not be able to see clearly. Okay, so that is called short sightedness or myopia. So now the question is, how does it happen, myopia? There may be many. Okay, so there are actually two main reasons. The defect arises due to eyeball gets elongated as long, like along its axis, so that distance between the lenses and retina becomes longer. Okay, and the second point is the focal length of the eye lens becomes too short due to excessive curvature of cornea. So you can see this, a myopic person can see, this is a normal eye. Look, this is a normal eye. Okay, let me first of all, let me tell you how we see any object. As I discussed, we have lenses in our eye, so you can see from this here. So when a ray from a point or any object, extended or point object, comes and get get refracted through this lens, then there will be image formed at the retina. And if the image is not formed by this lens at retina, then we cannot see the object. Okay, then we cannot see the object. So the object the image of the object has to be formed at the retina itself. Okay, but myopic eyes cannot do that. You can see from here. These are, see, myopic eye can do from near point. Okay, so this is actually, that means, you know, the far point comes to near. Any object you bring at this particular point can be seen clearly because this lens is making image on the retina itself. Okay, but if you take any parallel ray, look here in the first figure, parallel ray, where the image is formed much before the retina. So that's why myopic eyes cannot see far off object, or the rays which are coming from far off object. Okay, because the image after refraction by lens, human eye lens, the image is not created at the retina, rather it is created in between the lens and the retina region. Okay, so to correct this problem, that means if somebody has this problem that cannot see far off object but they can see small, like nearby object, and in that case what you have to do, you know, you have to somehow or other bring the very far objects at the near point of the lens of the myopic eye. Any object if you bring here, then myopic eye will, sorry, yeah, myopic eye can create the image at the retina itself, on the retina itself. So how to do that? Parallel rays, see these are the parallel rays, or the rays which are from the distant, like distant or very far off objects. They should come and fall on the sea. For this correction we are using a concave lens, and this concave lens, what it does, it creates a virtual image of the far off object at the near point of the lens or myopic eye lens. I hope you have understood this. To correct this problem, that a person cannot see the far off object but he can see the nearby object. So how to make that person unable to see far off object also? We have to use a concave lens, because this concave lens will create a virtual image. So you have to take the focal length of this concave lens such that it becomes equal to, like, the virtual image which is formed by this concave lens has to be at this particular point F. Okay, so we have to choose the focal length accordingly of this lens. Then we can talk about power of this. If we know the focal length, then 1 over the, or reciprocal of the wavelength is power. Okay, so we can talk in terms of power also. So this is how myopic or myopia, short sightedness, can be resolved. Now we'll go to hypermetropia. Oh, my screen got, okay, so in case of hypermetropia, I'll just No, this screen is freezed, so I cannot show you further slides. So then I'll stop it here. We'll take up few numerical problems on the next day. I hope my screen is not visible to people, I think.
Yeah, I can see Ram.
You can see the screen?
Yes, yes. Ray optic and optical instrument, right?
Yeah. Yeah. Myopia, are you able to see myopia or short-sightedness?
Yes, yes. Myopia or short sightedness. Yeah, is there.
Yeah, but I am not able to see the screen.
But I am unable to hear your voice. Ram, I can't hear your voice. Ram? Hello, Ram. I can't hear you, Ram. Hello, Ram? Ram?